So on page 11, this is a list of basic directions and the different kind of directions that we are going to be given to try to sketch some of our graphs, okay? Domain. Sometimes they'll give us the domain and say the domain, and that's all of our x values. They might give us the range. Intercepts. Whenever you have intercepts, those are very important points to make, okay? So definitely focus on the intercepts. We don't worry so much about symmetry. End behavior is good, and so is the extrema, okay? So definitely the intercepts, definitely the extrema, because they're going to give you certain points with those, and then maybe look at the end behavior, all right? So let's go to the top of the next page and see if we can actually sketch some of these graphs. Okay, I will take it in my hands. Thank you. All right. So for the first one, it says, use the key features of the function to sketch its graph. First of all, it says it is a linear function. If it's a linear function, that is going to be in the shape of what? What's the smaller word inside linear? Line. Yeah, this is going to be a straight line. So we need to keep that in mind, okay? All right, so here they give me the y-intercept, and that's at 0, -70. So 0 means I'm not going to the right or left, and I'm going down to -70. That is that point right there. So you make a great big point on that one. Okay? So that's a key piece of information, and I did that one. Now, it says it's linear. We already know that. Yeah. Is emergency? Okay. Give me just a second. It is positive, meaning it's going to be above 0 for values where x is less than -30. Positive where x is less than -30. Okay, so where do you see x is at -30? That's that point right there. That's where x is equal to -30. And it's saying, when I talked about all these values over here, it's going to be above that. You have 2 points now. You only need 2 points to create a line. Okay? So we've done this one. We did that one. Let's create a line connecting those 2 points. Now, if you have a straight edge somewhere, you might want to go ahead and use that. Like edge of your folder or a calculator or a notebook that's made of cardboard. Use that to create that line. Okay. All right, here we go, Crystal. Mm-hmm. Nope. 8, 9. Okay, so just check as we're looking at it, okay? Decreasing for all values of x. So as the larger we go to x, yeah, all those values are decreasing. That's true. As x is approaching positive infinity, so as we're going this way, does my graph go to negative infinity? Yes. As x approaches negative infinity, is the function or the graph going to positive infinity? Yes. So that is my graph. Okay? That is my graph. So it's looking at the directions they give you and then putting it together to create a graph. Any questions on that one? All right, let's take a look at example 2. Example 2 says sketch a nonlinear function. Okay? A nonlinear function. So it is not going to be a straight line. Okay? First up, it says, let's put in the y-intercept, that's a very important point, of 0, 3. 0, 3. Okay? So 0 means I'm not going to the right or left, and I'm going up 3. So I'm going to put my point right there. That is 0, 3. Okay? We already know it's nonlinear, so it's not going to be a straight line. It says it's going to be continuous, which means it's not going to stop. It's positive for all values of x. Okay? Decreasing. Now, some of these, we can kind of look at those later. Extrema. It says it has a minimum at 0, 3. Well, that's the point we just did. If that's the minimum, what does that mean? Means that's the lowest point. Okay? That is the lowest point. So keep that in mind. So as x goes to positive infinity, as we go to the right, the graph is going to go to positive infinity. That means it's going to go up. As x goes to negative infinity, the function goes to positive infinity. So as I go to the left, it's also going to go up. So as I look at this and I try to make it kind of look the same on both sides, it's going to be a curve like this. Can you put that away? Take out your notes. Okay. So it is looking at the directions they give and trying to come up with a plan. All right. Questions on example 2? All right. Last one. So it says to sketch a real world function. When we talk about real world type things, this is in usually quadrant 1, which means it is the quadrant right here. Okay, so this is just that upper right hand corner where you have a positive x value and a positive y value. All right, that's where a lot of real world situations happen. Okay, so follow along as I read. Hay is test driving a car she is thinking of buying. She decides to accelerate to 60 miles an hour. What does accelerate mean? If you're driving a car, what does it mean to accelerate? Going faster. Yeah, she's going to go faster to 60 miles per hour. And then she's going to decelerate. So she's going to slow down to a stop to test its acceleration and brakes. It takes her 15 seconds to reach her maximum speed. Okay? 15 seconds to reach her maximum speed, 15 additional seconds to come to a stop. Okay, 15 additional seconds to come to a stop. Use the key features to sketch a graph that shows the speed as a function of time. Okay, so y-intercept. This is my y-axis right here. Here's your x-axis, all right? Hay starts her test ride at a speed of 0 miles per hour. 0 miles per hour means she's starting right there in that lower left-hand corner. Okay? So we did this one. Linear or nonlinear? The function that models the situation is nonlinear. So it's not going to be a straight line for the entire thing. Her maximum speed is 60 miles per hour, which she reaches into her test drive. All right, so 60 miles per hour, 60 is way up here, and she reaches that 15 seconds, okay? So if you look at the bottom, this is your time. It takes her 15 seconds to reach 60 miles per hour. So 15 seconds, I'm looking down here, and at 60 miles per hour is going to put the second point right there, because it takes 15 seconds. Okay? Now, it says she is accelerating. She decides to accelerate. So we're going to connect those 2 points, because she is going faster. She starts at 0 miles per hour, and then we connect those 2 points. And then it says, hey, blanks the speed at a uniform rate for the first 15 seconds. Well, what is she doing with that speed if she was started at a stop? She wasn't moving, she is, well, not decelerating, she's increasing the speed for this part right here. So this is increasing. She is increasing the speed at a uniform rate. So that's why that part of the graph is a line. It's line segment, to be technical. Decreases or decreasing. Hey, decreases the speed at a blank rate for the next 15 seconds until she reaches a blank. So if she's decreasing the speed, is she doing it a little bit at a time? No, it's at a constant or a uniform rate. That just means constant. Okay, for the next 15 seconds until she reaches a, she's checking the brakes, so until she reaches a stop. All right. So she reaches 60 miles per hour. As soon as she reaches 60 miles per hour, it's going to take her 15 seconds to decelerate. How many seconds total is that then? So here's the first 15. Here's the second 15. So my new point is going to be right here at 30. And it says she is decelerating. She's going slower at a uniform rate. So we need to connect these 2 points like that. So the end behavior, because Hay starts out at blank miles per hour. So how many miles per hour is she starting out at? She's starting right here. How many miles per hour is that? 0. She's starting at 0 and she ends at, here's where she ends, 0, right? Because she's stopped. There is blank end behavior. Does it continue to go on, down? Can she go negative speed? No. So there is no end behavior here because there are definite starts and stops. Okay? Questions on that? All right. So we have one more graph to check on. I want you to try this one on your own. Okay? I want you to focus on the y-intercept, the x-intercept. Anytime you see numbers, you see points, I want you to focus on those You also have a minimum listed, and it says it's nonlinear. So I want you to try to sketch a graph. I'm going to give you a couple minutes right now and see if you can come up with that graph. Okay? And I'm going to walk around. All right, so catching up, our first point was at 0, -3. Next point was at -1, 0. Next point is at 3, 0. 1, 2, 3, 0. Okay. It says I have a minimum, a lowest point at 1, -4. 1, -4. Okay. If I put those together and it's nonlinear, it's going to be what we call a parabola or a curve. Okay. So I'm going to connect these points as best I can. Ooh, that was bad. Something like this. And you have a parabola. Now, let me check a couple of other things. As x goes to positive infinity, as it goes to the right, my graph is going to positive infinity. Yeah, that works. As x goes to negative infinity, my graph goes to positive infinity. So as I get to the left, my graph is going up. Yes, that works too. It's nonlinear, and where x is greater than 1, so right here, it is increasing. Okay? All right. So that is all the notes that we have today. Pay special attention. You should have given me homeworks 1 and 2. Now, homework number 3. I think it's only 1 page on the front. 1 page on the front. This is due tomorrow. Okay? So make a special big note to yourself. This is due tomorrow. I think it is just one side, isn't it? Isn't it? Yeah? Oh, it does have some stuff on the back. Okay. See if you can get that done for tomorrow, though. There are, what, 4 graphs maybe? Shouldn't take you too long. Basically, it's 3 graphs to sketch and 1 where you talk about some information. Okay? All right, one more thing as you are doing this. Okay? Everybody, eyes up here for just a minute. If you did not like the result that you got on your skills check, and remember, that's just a skills check. It's just like a homework grade. 21 points, so a little bit more than a homework, but then you need to change up something, okay? Maybe you need to look at your notes the night before. Maybe you need to make sure you really understand the homework or that you really ask questions when you're not sure, okay? The test is 1 week from today, and I want you to do the very best that you can, okay? So change something up to get a different or better result, all right? And if you're pretty happy with it, keep doing what you've been doing, okay? All right, that's all I've got for today, guys. Good job. No, it wasn't anything earth-shattering and totally awesome.